All right, so here we go. Welcome back, everyone, to semester 2. It feels like it's been forever. I guess it has been, about 2 months or so since we last met. So hopefully you have now forgotten everything you ever knew about Python, because we're on to Matlab this semester. Except hopefully you didn't, because I think all of you are doing your final projects for this class in Python. So hopefully you did not actually forget about Python. But this semester, at least in theory, we're moving on and talking about the wonder of Matlab. I don't know, did you guys actually, this may not cross cultural boundaries, did you guys read the book Harold and the Purple Crayon as small children? Okay, this is probably not one that makes, I actually don't even remember it myself, but it's about a little kid with a purple crayon and he goes on some kind of adventure of discovery or something like that. It's kind of like Where the Wild Things Are, or one of those kids' books. So anyway, I actually had an interesting discussion with John Pierce, the inventor of Psychopi, while I was in the UK. And he and I had a good, friendly argument for about half an hour as to which was better, MATLAB or Python. He is obviously irrationally biased towards Python. I personally am completely impartial, and I think MATLAB is a lot better. So unfortunately, we'll see if he actually, I don't think he's watching these podcasts, but we'll find out if he is. I'll probably get an email from him. Hi, John. No, it was a very friendly discussion, but he ended it after a while because I think he was getting sick of my logic. Anyway, so we're going to be doing MATLAB this semester, but obviously we're going to also be continuing to sort of refer back to Python and Psychopi. So, and of course, you guys will still be using it, hopefully fairly frequently for your final year, final projects for this class. Okay, so some updates. Okay, there we go. So that's weird. We're getting like very intermittent clicker activity. Okay, so like I said, Python and Psychopi are what we focused on first semester. The goal this semester is to focus on Matlab. That's the icon for Matlab, and PsychToolbox, which that's kind of the little icon that they have on the PsychToolbox webpage. One difference that we'll talk about later when we actually start using PsychToolbox is that PsychToolbox is not an application that you start up on your PC like Psychopi is, right? So Psychopi is a program that you install and run, and it has the Python language kind of built into it, right? But sort of the reverse is true of Matlab. Matlab is the software that you run, and it's the environment that you write code in. PsychToolbox is really just a collection of Matlab scripts. So what you essentially do is you install Matlab on your PC, then PsychToolbox is something that you download and put in a folder and kind of install separately, but PsychToolbox requires Matlab to run because PsychToolbox is written in the Matlab language. You guys will not have to worry about downloading and installing PsychToolbox. I'll handle that on these PCs. That's just worth knowing. I mean, so the two pieces of software are very similar in that, like, Python is a programming language and a programming environment of some sort, and MATLAB is a programming language and a programming environment of some sort. And Python is Psychopi, is essentially a collection of Python scripts, whereas PsychToolbox is essentially a collection of MATLAB scripts. But the difference is kind of how they're packaged. So John has conveniently packaged up all of the Python language inside Psychopi, so you just have to run Psychopi. PsychToolbox is a bit different. Once we get to actually using it, you'll kind of see how that works. Okay. So today, our scheduled topic, as we got through pretty much all of our Psychopi stuff last semester, except for a couple of the bonus topics. Today, we are scheduled to talk about similarities and differences versus Python, and I will be talking to you a little bit about that. But we'll get into the details of exactly how much we're going to talk about that in a second. As far as your problem sets and project proposals are coming, I know at least one of you has expressed some concern about the getting back of those. Some people seem to be suggesting I'm playing too many games on my iPad and not enough time grading. But let me assure you, I've been spending lots of time on your problem sets and project proposals, and I've almost done marking them. I only play the iPad games when I'm too tired to, exert the cognitive effort required to give you good feedback and everything. So that will hopefully be coming tonight. I've looked through most of the project proposals and marked them. Problem set 5 is totally marked, but I figured I'd just send you guys back everything at once. Problem set 6 I still need to mark, but I've got the key down, and so the marking should go pretty quick. So I'll send you guys back all of that at once, but I think from my first pass of reading through the project proposals and with talking with you guys, because I pretty much did that with everyone, everyone's project proposals look pretty good. Everyone's ideas, I think, are basically solid. There was variation in how much people planned ahead, and how realistic I think some things were, but hopefully you guys have not been waiting on my feedback to start planning more of these projects, because really the proposal was just a chance for you to put into writing for a grade what we'd already talked about in the plan. So hopefully you guys have already been making some progress on your projects. I made a little bit of progress on mine on a train, and I can maybe show you mine later on, but I'm not all the way there yet either. So that'll be coming soon. Any other administrative stuff or general stuff to talk about that you guys need to bring up? Everybody good? Okay. So before we get into the Python versus MATLAB, I'll tell you the situation with MATLAB. So we don't have MATLAB yet in this room. So today's lesson on MATLAB is going to be a little bit short because you guys can't run MATLAB, and I only have 2 laptops with MATLAB on them, so I can't exactly have everyone share to do the demos. So I'm going to talk to you a little bit about the theory, because that's sort of what I did first lecture of last semester, but we're not going to get into it probably until a week or 2 from now. So hopefully, it probably won't be here next week either. We're working, I'm harassing IS and finance and everyone. Apparently it requires a signature from God himself to approve the budget. So it actually, I think, requires a signature from the CEO, who is, new to the campus. I don't even know if she's here yet. So anyway, we will get it installed as soon as possible. Then you will have access to MATLAB and PsychToolbox. It's probably going to cut down a little bit of the amount of detail we get into MATLAB this semester, but we're still going to have hopefully 8 solid MATLAB lectures or so. And I think you will learn MATLAB much faster than you learned Python, because a lot of the principles are the same. So I think I've said this before, but sort of the good news is that there are a lot of concepts. There's still things like for loops and while loops. They're written a bit differently, but the concepts are the same. So the good news is, if that makes sense to you, it's still good news either way. The good news is, if it makes sense to you, hopefully this will be pretty easy and will go pretty quickly. The good news, if you are still struggling a bit with that stuff in Python, is you get kind of another pass through it in another language. And I'm hoping that the minor differences in how you phrase certain things will not, I'm hoping that won't confuse you, and that you'll see the core similarities that are here between these 2 languages. But anyway, so what we're going to do today, I'm going to talk to you a little bit about MATLAB. I'll show you a couple little demos and things that I can show you from my computer, but I think it is important that you guys get to play with this stuff yourself. So we're not going to do too much of that today. Like I said, about the last half of the class today is going to be kind of supervised project time. So, it'll be no judgment. If you haven't started your project yet, I will not judge that, but you'll have at least an hour of interesting to see who reacted. No judgments, but I figure this is actually maybe a good way to start out, because this will give you an hour to kind of force you to start working on it. I'll be around to supervise and answer questions if you've made enough progress to want to discuss this. And so it'll be supervised project time, which was sort of built into the semester already, but I had planned to do it at the end. So anyway, we'll do that for the last hour or so of the class. And we'll probably do that next week too. Maybe I'll have to think about how we can do next week. That might be the whole class period next week. And it might be, I might give you a little bit of lecture or something. We'll see. Also, by the way, that will also probably push back the problem sets a bit. So what I'm warning you of is that I had designed this semester to be mostly all the problem sets in the beginning, so that you guys would have time at the end to panic and work on your problem sets. I'm sorry, on your projects. It may not be, I'll probably have to push back the problem sets by at least a week. So I'm still going to be very careful about not overloading you with problem sets this semester, but just, if you're thinking about how to arrange your time throughout the semester with your other modules and such, maybe think about working a little bit more heavily on your projects for this class, earlier on, so that you're not panicked at the end. Okay. So a little bit of other just comparison detail. This is stuff that you don't need to play around with to know, but this is to just sort of like orient you as to, if you were continuing a career in research and you were programming experiments regularly and you had to say, well, in my research, should I use Psychopi or Python or Matlab or PsychToolbox? What should I use? Here are some things to consider. This is more practical stuff. So one thing to keep in mind, I think I mentioned this before, is that Python is totally free, which is a huge advantage if you don't have a lab with a lot of money. Matlab is extremely expensive, so it varies. The pricing of Matlab is one of the most complicated things in the universe. Like the laws of Matlab pricing are very difficult. It depends on like what country you're in, how many copies you're buying, whether you're doing like a university license or an individual license, or like a limited number of licenses, or how many you're running at once versus how many machines you're installing. It's very complicated, but it's very expensive. So it's going to cost us, I don't know, like 100,000 ringgit or something like that to put MATLAB on all these PCs in here. So hopefully it's very useful for our research too. So it's not like this is just for this class that I was pushing for this. But it's very expensive. Now the good news is at a lot of major universities, especially like the really huge universities like the ones in the States or UK or whatever that have maybe 50,000 undergraduates, a lot of these universities have a university-wide license for MATLAB that anyone can just download and install it. And hopefully no one from Yale is watching this podcast and realizing that I'm still running Yale's copy of MATLAB on this laptop. So that's something to think about though, right? So if you were starting up your own lab and you didn't have access to a university site license, you might go with the free thing instead of the expensive thing. Just like you might use OpenOffice instead of Microsoft Office if you don't want to pay for it. The other option is, of course, to pirate things, but we don't recommend that, especially for our official university work, right? Okay. Other things, you'll find quickly when we start working with MATLAB, Python and Psychopi have a fairly basic user interface. You guys have all used it. Python, the language itself, has no true user interface, really. But Psychopi does have a bit of an interface, right, where you can type things into the editor and click buttons to run stuff and so forth. What you'll find, is that MATLAB as a commercial product is much more polished. There's a lot more nice little bells and whistles. The user interface works a bit better and so forth. But, it's just sort of the usual thing between something very expensive and something kind of open source and still at the beginning of its development. So, MATLAB is going to be a lot more polished and have a lot of nice little tweaks for you. And I'll complain a little bit. They've actually taken MATLAB in the same direction as Microsoft Office with like adding that ribbon thing and taking away the menus and stuff, which actually I don't like. They've sort of over-polished the user interface in my opinion. But at any rate, you'll find that there's a lot more, there's a lot more sort of nice little features in MATLAB. The Python language itself is a very general purpose programming language, right? So Python is used a lot for web applications, general type software. You can write basic games with it. You don't have to use it only for psychology and neuroscience and scientific computing, right? MATLAB, you could write a game in MATLAB, but it would be a game that required a several thousand ringgit piece of software to operate, and would really not be like, it's not optimized to do sort of general purpose computing tasks. MATLAB, it stands for Matrix Laboratory. It was originally designed to do matrix calculations. It's for scientific computing where we're often working with large data sets that are in kind of blocks of data. So if you think about EEG data, I know you guys haven't recorded EEG data, but you know what it is. In EEG data, you've got, say 128 sensors on the head, each of which is recording data, say 250 times a second or something like that. What you can imagine that is it's a really big matrix of data, that's 128 rows long and then however many time points, many time points long. And that's sort of what you get out of EEG. fMRI is very similar, except the matrices have more dimensions. An fMRI, you guys haven't worked a lot with matrices yet, I know, but fMRI data, if you measure fMRI data, basically comes out as a 4-dimensional matrix because you've got a bunch of numbers representing the activation values at each point in the head, and that has an X value, like, a value in this dimension, a value in the y dimension, which is this way, a value in the z or z dimension, which is this way, and then time, right? So, fMRI data is really just a giant four-dimensional matrix of numbers also. So that's the kind of stuff that MATLAB's really good at working with. Python has a lot of modules for doing scientific computing and so forth. But the whole language is not as a whole designed to do this kind of stuff. So what you'll find is that MATLAB, numeric things are a lot more natural to do in MATLAB, but Python can do a lot more sort of general purpose stuff with less effort. So it sort of depends what tool you're picking for what purpose. All right, one big thing that will blow your minds this semester, I think, once you start working with MATLAB, is the MATLAB debugger. So Python doesn't have, Psycopi does not have a built-in debugger. There is debugger software available for Python, but it's not built into anything we've used. So there's no default debugger in Python. MATLAB, one of the greatest things about it is if you are trying to figure out what's wrong with your code, you guys have had this experience, I think, where something crashes or it gives the wrong value or whatever. You can literally do what I was sort of encouraging you to do by hand last semester, which is run your code one line at a time, not just sort of wait for the output, but stop the running of the code, every line through the code, look at what all your variables are, see what values they have. You can figure out when the code is jumping to a point that you didn't think it was supposed to jump to. It is incredibly useful, especially once you start writing more complex code. So maybe I'll show you a little bit of how the debugger works today, just to sort of open your eyes to how wonderful it is. So that's one nice thing about MATLAB. Similarly, MATLAB also has something that it may not be super useful to you guys just yet, but in the future, if you stay with it, will be very useful, which is code analysis. So you guys old enough to remember the paperclip guy that used to pop up in Microsoft Word, where you open a document, it's it looks like you're typing a letter. Would you like me to open up the letter template or whatever? So it's not as annoying as that, but it's the same kind of idea where MATLAB's actually smart enough to be analyzing your code as you're writing it. And if you're writing some code and it's that's not going to work right, that's a syntax error, it will tell you as you're writing it, it won't wait for you to run it. It'll put a little, how Microsoft Word underlines your misspellings with little squiggles. It basically does the same thing. It puts a little squiggle, you mouse over it, and it's this isn't going to work because you forgot to close your parentheses. Or this isn't going to work, because you didn't give enough arguments to this function or something like that. And it will even give suggestions for improvements to your code, oh, this will run faster if you use this function instead of this function. Which again, may not matter to you guys right now when your main focus is just getting stuff to work, but it's super helpful when you're, if you start running fMRI analyses that take, I've run analyses that take a day and a half to run. And if it tells you hey, you could change these 2 lines of code and run it, 50% faster, that's a huge help, right? Okay, lastly, we talked about this. If you're doing psychology experiments, you would use the Python language with the software Psycopi, and you would use, in MATLAB, the software called PsychToolbox. So just comparing those two things, Psycopi and PsychToolbox, specifically, not the languages they're built in, some things to keep in mind. One advantage of Psycopi is it has a builder interface, right? Now, we have been discouraging the use of the builder interface in this class, but you guys, I think most of you have probably played around with Psycopi enough that you've seen how it works. It's sort of like ePrime. PsychToolbox, no graphical interface whatsoever. It is all done in code. There's no option to build your experiment by dragging things around on the screen, right? So PsychToolbox is only for people that can code. Psycopi sort of straddles both, the code boundaries and the graphical interface boundaries. What you'll find is that the hardware support is a bit better in PsychToolbox. So for example, I think you guys might remember we talked about how in Psycopi it's a little bit tricky at least on the computer hardware we have here, it's a little bit tricky to get precise timings for when your stimuli come on screen. And what we should find is that PsychToolbox is actually a bit better with that. So in general, some of the weird issues we had with the sound not working and things like that stuff will generally run a bit better on PsychToolbox. Again, partly because it's a bit older and just because it's been developed over a longer period of time. A lot of those bugs have been ironed out. Similarly, because it's an older product, I think the documentation for PsychToolbox is a bit better. If you go onto the PsychToolbox website, you will get very extensive documentation on how everything works. Psychopi is pretty good for that, but it's not always 100% up to date. And then, like I just said, Psychopi is quite a bit younger. It's only a few years old. PsychToolbox, I meant to put in a slide about this. PsychToolbox is very old. So the first versions of PsychToolbox were written back in like the 1990s. Like, I think some of you were probably, yeah, you guys were kind of like born around the early 90s, right? So PsychToolbox is probably nearly as old as you guys were. You were probably like small children when the first versions of PsychToolbox came out. And because of that, like, it actually was first written for the old Macintosh. Its language looks very much like, I only know this because I was a nerd in high school, and I like to build apps for the old school Macs. And it looked very much like the way that you wrote software for the old Macintosh computers before OS X existed, before Intel processors, before all of that. So it's quite old. That sort of shows in the code, but it's actually updated very regularly. So although the style of the code is a little bit old-fashioned, it's very much up to date all the time, and it's constantly being revised and updated. Okay. So one last set of comparisons, and then I'll show you some demos, and then we'll go on to work on your projects. What time is it? Okay, yep. So if you guys remember last semester, we talked a bit about the difference between object-oriented and procedural programming, right? So like Python, we said was very object-oriented, even more so than it seemed to be at first, right? Because we said that you can even treat things like integers and strings and things like that as objects, right? That means that variables in your code not only have information, they can do things, right? They can do things with themselves. They can maybe do things to other objects or whatever. Matlab, although it does have some support for object-oriented behavior, you should think of Matlab as a mostly procedural programming language, meaning you write functions and you have data that goes into the functions and comes out, but you don't really, nothing that we do in this class anyway, will involve having objects that can do things. It's always, when you're doing something to data, you're always using a function, putting data into it, getting data out of it. You're not ever having an object that sort of bundles up its data and its functions or its behavior together. Okay? So that's going to be a bit of a difference in style, but we've sort of done both with Python so far. So it shouldn't be too weird for you. There's some differences in how the external functions. So we talked about importing modules a lot in Python, right? MATLAB's a bit funny. We will get into this more when we start using it, but MATLAB, just like your code files in Python end with .py, MATLAB files end with just .m, which stands for MATLAB. So they're called M files usually. And one weird thing about MATLAB is you don't have to import M files the way that you do in Python. So there are certain folders on your system that MATLAB knows to look in, and basically, if there's an M file in one of those folders that hasn't, that's file name, if the file name matches the function that you're trying to use, it just assumes that the function you're trying to use corresponds to that file, and it looks in that file. So you don't have to explicitly import things. So the nice thing is you don't have to explicitly import things. The bad news is you kind of always have to be aware that you're putting your runnable MATLAB files in the right folders so that they can find each other. So that's sometimes an issue if you tell MATLAB to change directories or something like that, and then you try to call some function that was in the previous directory and then it can't find the file. So that's just, we'll talk about more of that later. We're going to try to mostly avoid any issues that come from that. But just keep in mind that you don't have to import any modules, but you might have to tell MATLAB where your M files are sometimes. Okay, and again, maybe that may not make a lot of sense right now, but we'll show you more how that works later. Okay, last thing, and probably the biggest difference, and I'll show you a little bit of this today, the biggest kind of weird thing to wrap your mind around is the way that data types are handled in Python versus MATLAB. So Python uses a pretty traditional approach where you can have data types like integers, floating point numbers, you remember, that can represent decimal information. You can combine these things in lists or tuples, or you can have text stored in strings, right? And then you can also have objects of all kinds of types like windows and mouse objects and clock objects and so forth, right? That's how Python does it. The thing to note about MATLAB, it's got things like floating point matrices, strings, something called structs that we'll talk about later, something called cells that we'll talk about later, and it sort of has integer matrices. But the thing to point out about Matlab, which is going to be the hardest, I'll tell you right now, the hardest thing to wrap your mind around, is that really every piece of data in Matlab is treated as some kind of matrix. Meaning, in Matlab, like in Python, an integer, if you define an integer variable, it's just a number, right? Like it's the number 7 or it's the number 4. And yeah, you can treat it like an object and make 4 do some things, but it's still just a single number. And if you want a lot of numbers, you have to put them into a list or a tuple, right? In Matlab, even a single object is treated as a matrix, meaning it's not really, you can't ever have a thing by itself. If you have a thing by itself, it's really a 1-by-1 matrix, which is equivalent to a thing by itself, but it has some implications for how you deal with data. So the way to think of it is, think of all your variables in Matlab as, if you think about Python, if you were like writing down what all your values are, you could think of like writing them down on just a completely blank sheet of paper wherever you like, right? In Matlab, think of it as like everything's in graph paper. And if you have a single thing, it goes into a single box in the graph paper. If you want to have a matrix of things, so like a row of things or like a two-dimensional matrix of things or whatever, you can have that. But everything has to be in some form of matrix. So that has a lot of implications with how you organize your data. So for example, strings, I put them in quotes because strings are really just a specialized type of matrix. What strings are really a list of numbers or a matrix of numbers that Matlab knows to interpret as text. And so you can do things with strings in Matlab that you couldn't do with strings in Python. And really in Matlab, strings and numbers are not so different. And the reason I put integer matrices in quotes is because there is a way to tell Matlab that things are just integers, but 99% of the time, the default data type in Matlab is to just make everything floating point. So we are pretty much only going to be using floating point numbers in Matlab, even if they represent integer values. Okay, so all that stuff we had to do in Python about making sure, like when you divide 5 by 2, in Python, 5 divided by 2, if you just type that out, anybody remember what that gives you? Gives you 2, right? So it throws away the remainder. In MATLAB, it'll tell you 2.5. It just assumes everything is floating point by default. And if you have something like we said, it is sort of technically impossible in a computer to represent an exact integer value with a floating point number. But if you have something like 1 point or 2.000000000000001, it just displays it as 1, as 2 for you, right? So it has some smart things built in where it knows when to show you things as an integer and when to show them as a floating point. Okay, so real quick, because I'm tired of just talking, I want to show you some of this stuff. Just to run down the advantages again, we said PsychToolbox and Matlab have a more polished interface, a really great debugger, this real-time code analysis. One nice thing is that you can do everything that Matlab can do in general to design your tasks. So again, this may not help you guys this much because you're going to be just getting into this, but when you get into really advanced stuff, this is super useful. So like, I wrote some tasks during my PhD that if I had to present an image and then a mask, I could I could take a bunch of images and select little pieces of them and scramble them up in real time to make masks in my task, which you could do with Python, but it's much, much easier to use MATLAB's image processing functions to do that same thing. And similarly, it's got great functions for doing statistics. So if you want to do t-tests and ANOVAs and things like that in your task, again, you might be able to find a module in Python that you can import to do that, but it's all built into MATLAB. Similarly, it's great for data plotting and so forth. So MATLAB has a lot of really great functions that can be used if you want to do fancy things like, process the data in real time. So another thing I did was do a task that involved eye tracking, and while the person was doing the task, it would keep track of how accurate their eye positions were, and at the end of each trial, it would get feedback saying, you successfully fixated on the target 95% of the time. Which again, you may be able to figure out how to do it in Python, but it's much more natural to do it in MATLAB because all the functions are pretty much built in. Another nice thing that you guys, again, aren't worrying about now, but will be helpful in the future is if you ever do neuroimaging, you will probably not be able to escape MATLAB, at least for the next 5 to 10 years. Python is growing in popularity, and people are getting into doing neuroimaging with Python because it's free, basically. But for right now, most of the major neuroimaging software packages like SPM for fMRI, EEG Lab, and Field Trip are common ones that you use with EEG or MEG. These are all collections of MATLAB scripts, just like PsychToolbox. So if you want to present your task and analyze your data in the same program and only have to know one programming language, super helpful to use MATLAB. It's a little harder to do it with Python. Easier to do all kinds of complex calculations and matrix math, and again, matrix maths. And again, that's why a lot of this neuroimaging software is implemented in MATLAB. And like I said, with certain PC hardware, some things will run better than in Psychopi because it's got a little bit better hardware support. We've talked about the disadvantages mostly already. High cost, it's closed source, right? So you have to pay for it. I say sort of because there is this software, I think I might have mentioned it early in the class, called Octave, which is meant to be sort of an open source replacement for MATLAB. It's getting there. So I considered installing Octave on all these PCs for this class, but when I learned that we could possibly get real MATLAB, like real MATLAB is 100 times better. So Octave has no graphical interface. It has sort of spotty implementation of some stuff, so it's a lot harder to work with than MATLAB. So you could kind of get a free open source version of MATLAB, but it's still a few years away from being like actually good to use. So if you can afford MATLAB, it's a lot better than Octave. So for the most part, if you want the open source version, Python's better than MATLAB, I'd say. But if you're willing to pay, then it's closer to an even trade-off. It's less good as a general purpose programming language. So Python is a lot more useful if you want to say, forget about psychology, I want to go be like a web developer. There's a lot more sort of general purpose programming stuff in Python than in MATLAB. So if you wanted to write games or whatever, there's a lot more of that stuff for Python than MATLAB. Although MATLAB, I will confess to doing sort of generic computing tasks, like if I want to rename a bunch of files, or if I want to, I don't know, like what else have I done? I've definitely written a lot of file renaming programs. Like sometimes I'll use MATLAB instead of something like Python because I know it better. So you can use MATLAB for sort of general purpose tasks. Like I said, you could write a game in MATLAB if you really wanted to. But generally speaking, it's not as useful. And the main disadvantage for you guys is, although you can do a lot of really sophisticated stuff, it will be the case that simple tasks will require a bit more code and like more bookkeeping. So Python sort of hides a lot of or Psychopi kind of hides a lot of the details from you. In PsychToolbox, you have to keep track of a few more details, okay? And we'll sort of see how that goes as time goes on. So the disadvantage is that there's a little bit more of a learning curve, but you guys have already learned Python, so hopefully now a little bit more of a learning curve will be okay. Okay, so this I forgot I had the slide in here, so I've already kind of alluded to this. So just like in Python, everything is actually an object. In MATLAB, everything is actually a matrix. You may have noticed that I said there was no list, or I didn't say there was a list data type in MATLAB because everything is a list. It's actually a matrix, right? So the only difference, a list is one-dimensional, meaning it's just a list of things in one direction. A matrix can be 2 dimensions, meaning it's like a grid, like this. It can be in 3 dimensions, meaning if you could imagine a bunch of little points stacked up in a cube, right? Where each point is a number, that would be a 3-dimensional matrix. And then it could be a 4-dimensional matrix, which your brain can't really imagine in space, but you can imagine a bunch of little 3-dimensional boxes kind of stacked up in a row, and so forth, right? And everything, even single values, actually even empty values. So even when you represent nothing, nothing is actually represented as a matrix with 0 objects in it, which is, it's like an empty box, basically. But there's no way to have the thing outside of this matrix box. And again, that has some more mathematical implications that you may not necessarily need to know about. Okay, so I think it's demo time. We'll do a few quick demos just to sort of introduce you to MATLAB so that it's not totally foreign when you start playing around with it. And then we'll have sort of guided time for the rest of the time here. So I guess before we launch MATLAB, any questions or anything? Everybody good so far? Everybody excited about at least, this is kind of a tease. I'm kind of like, you can look at it. You can't yet touch the MATLAB, but hopefully soon we can touch it. Okay, so this is MATLAB starting up. This is actually, maybe I'll change this for next week. This is actually, they release a new version of MATLAB about twice a year. It's on a very fast update cycle. This is the version from late 2011, which actually is before they added this funky ribbon and took away my beautiful menus. So it's going to look a bit different. Probably, let me just see actually. I can't remember if I actually put the newest version on this laptop. I think I did not actually. Yeah, so maybe I will suck it up and put the new version on this laptop so that my interface looks like yours, even though I don't like it as much. But the basic principles are still the same. Okay, so here's MATLAB. I'll sort of walk you through the interface just so you can see what it looks like. So this is sort of the, I think it's the default interface. If I want to go to the default desktop layout, I can do that. Yeah, it looks basically the same, except I zoomed the window up a little bit. So let's make you all the way big. All right. So this is what MATLAB looks like. What you'll see here is, by default, there are different like panels that are in the main interface. This is just sort of a file. This is a directory with like files in it. So this just shows what's in the current folder. So that's kind of useful if you want to like open up a file or something. Apparently, I was working with triangular numbers in MATLAB. This might have been, I won't open that because that might have been a plan for a problem set that I've since forgotten about. But you can see like the current files in this folder. So if I want to like go up a folder, I can do that various ways. I can like, apparently I can't do it that way. I can go up here, go up a directory into my documents folder or whatever, right? So it shows you the current folder up here, but it shows you what's in the current folder over here. It'll show you some file details if I click on the file. But I don't usually use those too much anyway. The main thing that you want to worry about is this big window, which is your command line window. Okay, so this is, you guys remember in Python, there was the place where you sort of type in your code and save it, the code editor, right? And MATLAB has one of those too, actually. I'll show you that right now. I can launch the code editor by typing edit. And that'll bring up, in MATLAB it's a separate window. It's not two panes of the same window. So here's a code editor where I can type in whatever code I want for MATLAB, okay? And close that, don't save. So that's a separate window. Now if I want to be like totally lame about it, I can do it with the graphical interface by saying like new script or something like that, and that'll bring up the editor too. But that's boring. It's much, real nerds use the command line as much as possible, so we type edit to open up the editor. And if I wanted to open a specific file, I could type edit, like myfile.m, and it would say, do you want to create myfile.m? And I could be like, sure. And so, you know, here's my file, okay? So anyway, so this is the command window. One nice thing about MATLAB is, I think we had some issues working with the Psycopi command window. In MATLAB, the command window works much better. So the command window is great for just sort of trying out some code. When you actually want to, you know, finalize code and save it in a file, you want to use the editor. But if you're just trying to like figure out how a line of code might work in MATLAB, the command window is great. So once you really become like a pro user, you'll find yourself kind of flipping back between the code you're writing in the editor and the command window to like try stuff out quite a lot. And it's also useful because the command window is where you can get simple help on a function. So like, what's a good MATLAB function? So let's do, okay, so here's a good, you won't know what this is yet, but if I want to know what the function flip LR does, I can type help that, and it tells you, oh, actually this is pretty useful help. It'll be like flip LR with one input, you know, that it's calling X right here, returns X with row preserved and columns flipped in the left-right direction. So if X is 1, 2, 3, 4, 5, 6 like that, if you flip it left to right, it becomes 3, 2, 1, 6, 5, 4. All right? So it gives you documentation on that. If you wanted to get more substantial documentation that's more graphical, you could do what it says here, which is to type doc flip LR, and that brings up this kind of slow but more graphical version of the documentation. So again, you guys may not be using this that much. Actually, all of this documentation is also online, so you could just Google a MATLAB function and it comes up on the company's website. But it's super useful once you really know what you're doing, because you don't have to remember how these little functions work. Or like, with Psychopi, it's great to have all the documentation on the website, but it's a little trickier to get the full documentation for something, right at your fingertips. Here, it's very easy to get a very nicely formatted piece of documentation. Okay, so anyway, the command window's here. One nice thing you have over here is your command history. So if you want to bring up a command you've recently used, it's right here. And another great thing about that command history is it remembers what you typed. And there are a bunch of little shortcuts you can do if you want to reuse a line of code again. So if I was like, oh, I want to check out the document or the help for flip LR again, I can just type H, and then I can hit the up key, and whatever previous command I had that started with H will show up here. And if you go back in time, you'll see, well, I haven't done many other commands that started with H, I guess. But if you wanted to see all the commands I did previously in using MATLAB with S, I could do like this, and look at, this is various stuff I've done with starting with S in the past, right? And if I wanted to narrow it down, I could type SP, type up, and look at all the functions I previously called with SP. Now, if you ever try to do anything really naughty with MATLAB, just remember that it's remembering everything you do, but there's not too much naughtiness you can actually get up to with MATLAB, so unless you really try. That's kind of nice that it remembers everything you did. So that's what's down here. And then the last thing up here is the workspace, which again is really helpful, but there's nothing in it yet. What the workspace does is it's sort of like what I said where you're writing down all your variables on a sheet of paper. That's going to be the sheet of paper that shows you what's in all of your variables. So let's actually write some actual very simple MATLAB code and show you kind of how all this works and how you might use this to sort of play around with things in real life. Okay, so just like in Python, if you want to make a variable, I'm just going to call it A for right now, but I could call it anything. I could call it, Bob or my variable or whatever, right? But just for quick typing, I'll call it A. If you want to create a variable and set it equal to something, you just type A equals whatever you want it to be, right? So if I want A to be 5, I just type A equals 5, and it gives me a little feedback. It says, okay, now A is equal to 5, right? Now, if I get sick of that feedback, that gets very complicated really quickly. So like, let's say you don't know how to create random matrices yet, but you're about to. If I want to create a random matrix that's 100 by 100 items, I don't really want to show, because what's going to happen is I get that, right, which is a lot of numbers. I don't necessarily want to look at that every time. So one thing you can actually do in MATLAB, you don't have to do this in Python, but in MATLAB, it will print the result of every line of code you write unless you put a semicolon on the end of it, right? So I put a little semicolon on the end of that, and it'll just do what I said without printing it, okay? So that's one minor but important difference between MATLAB and Python is like every time you leave out a semicolon in MATLAB, it tells you the output of whatever just happened, okay? So sometimes you want that, like if I want to see, if I want to see what 3 random numbers look like, or sorry, a matrix of 3 by 3 random numbers, I might want to actually see that. But if I don't want to see the result of something, you have to remember that semicolon. One great thing about the MATLAB editor is every time you don't end a line with a semicolon, it gives you a little squiggle to remind you that whatever line of code you just wrote will produce output. So that's good to keep in mind. All right, so let's say we have A equals 5. We said, all right, it tells us that A is 5. But if we wanted to suppress that, let's say A is now 6. It just sets A equal to 6, and it doesn't actually tell us again what we just did, right? Now, you can confirm that because up here, we have our awesome workspace where it lists all of our variables that we've created and what their value is, right? So we see A is up here, and it's set to 6. If I change that again with another line of code, let's say it's now 7, that instantly updates A to 7, right? Now this, if you have like 500 variables going on, it gets kind of crazy to like, to see what's going on here, but it's still very useful for like a small number of variables. And if you do have too many variables, or you can't quite see, you see that like we've got, we've got B, which we created just a minute ago to be a 100 by 100 matrix of random numbers, right? But we also have this thing called ants. Did you guys notice when ants came up? So what did I type that first made the word ants appear in the output? Do you guys notice that? So it happened up here when I just typed the command to generate a 3x3 grid of random numbers, but you notice I didn't assign it to a variable. So that's another little thing to keep in mind, is that whenever you type something in MATLAB that doesn't assign the output to a variable, it puts the output temporarily into a variable called ants for like answer, right? So if I want to know what like 5 plus 3 is, it'll tell you the answer to that is 8. And it will automatically create this variable called ants, which has 8 in it, right? Which is kind of useful. It's like a calculator that sort of stores the last result in its memory. So if you want to like do a bunch of calculations, like now I could just say ants plus, 2 more, which will tell me that's 10, but it will also update the value of ants to 10, right? So ants is very temporary. It's just to show you the last output that was created. But anyway, if you look up in the workspace, so we've got A, which we created and set to be 7, ants, which we set to be 10, and we got this B, which we said was a 100 by 100 random matrix. So you see when it asks what the value is, if I sort of extend that a bit, it says it's a 100 by 100 matrix, and double is the MATLAB word for a floating point number. So it means it's double precision, which means it's a very precise floating point number, and double is the default data type in MATLAB. So pretty much everything is actually a double. So that'll tell us like what is in B, although it doesn't tell us the exact values. If we want to see what B actually is, first let's make B something smaller. So let's make it a random matrix that's 4 by 4. Okay, so there's B. If you look up in the workspace browser, it shows you that B is a 4 by 4 double. It'll tell you some helpful other things if you scroll over, like what the minimum and maximum values in B are. That might be useful sometimes. I don't use that very much myself, because there are other ways of finding that out. But if you want to see what B actually is, you can just type the name of the variable in the workspace, and it'll tell you what the variable is, right? And similarly, if I forget what A was, and for some reason I have hemispatial neglect and I can't see the right side of my screen, I might type A, and it'll tell me that A is equal to 7, right? Everybody cool so far? Everybody down? So far, nothing too weird, I don't think, about the language. In terms of like typing in numbers and assigning values to variables. It's just sort of getting used to this window interface. Okay, so let's look at some things about how MATLAB works then. So, like I said, everything in MATLAB is a matrix. But when you just type in A and it tells you A is 7, you may not be inclined to believe me, right? Because A just looks like the number 7. So just to prove it to you, how MATLAB is really representing A. Oh, by the way, you notice if you type a function and wait a second, it tells you how to use the function, which is very nice. If I want to see what the size of A is, so that's a function that's built, one of many functions that's built into MATLAB. Size is a function that tells you how big a matrix is, okay? So if I say size parentheses A, the answer is 1 by 1, right? So that's telling me that, okay, A is not really just a single number. It's a 1 by 1 grid of numbers, right? So in other words, if I ask what the size is of B, it tells me 4 by 4 because B looks like this. It's a 4 row by 4 column matrix. Again, don't try to memorize all this right now. This is just kind of starting to introduce you guys to the idea that everything's a matrix in MATLAB. Probably we're going to mostly be using two-dimensional matrices in MATLAB, which is good because they're easier to represent on a two-dimensional computer screen. So just to get you used to how they're displayed, let's make B a matrix that's like, let's set it equal to a random matrix that's 2 by 5 numbers. Now, anybody know, this is kind of reaching back into linear algebra or calculus or whatever. Anybody know whether 2 going to be the rows, like the number of horizontal rows, or the number of vertical columns? Which of those is the rows and which of those is the columns? Anybody know? I wouldn't necessarily expect you to. The answer is the first number is always the rows and the second number is always the columns. So if I say B is going to be a 2 by 5 matrix, and I can prove that by asking what the size is of B. Size of B is 2. This gives me 2, 5, which means it's a 2 by 5 matrix. So that means it has 2 rows down and 5 columns across. Okay. So here's a question for you. what if I don't want a 2 by 5 matrix? Like, what if I want B to, like, what if I want to get rid of this value and just have 2 rows where there's nothing in the last value? Anybody know what I mean, you don't know the language of MATLAB yet, but anybody have an idea about what you could do there? All right, well, it's kind of a trick question because this is one of the things you have to think about when you're working with matrices. The thing about matrices is they can't have empty values in them, or they can't have truly empty values in them. So you can't have, like, the definition of a matrix, right, is that if it's a 2 by 5 matrix, it has 2 rows and 5 columns, and there's something in each of those columns, right? So you could do various things if you didn't want that number to be there. So you could say, and again, don't worry about the details, but if I want to set just that one value to something, I could set it to be 0, which might be good enough, right? Depending on what I'm doing, I could maybe say, well, if I know it's 0, I know I can ignore it or whatever. But I can't set it to be nothing at all. Probably the best thing I could do would actually be to assign it to a little special something called nan. Anybody know what a nan is? Again, I don't know if this is anything you would have ever encountered before. It's not a number. What is it? It's a special number that's called not a number, okay? So it's still a double. It's still it's represented in the computer as a number, but it's a number that means not a number. So there's 2 special numbers like that in MATLAB. There's nan and there's inf. Anybody know what inf is? Or what that stands for? What's another number that's not expressible as a numeric value and starts with inf? Yeah, 1,000 divided by 0 is inf. So what is inf? Yeah, it's infinity, right? So there are some weird special numeric values so that if you want something to, like, sort of be empty in a matrix, you could set it to nan or inf or something like that. Nan would be an example of, like, 0 divided by 0 is not a number, right? So that means, so one nice thing is that in old-fashioned computers, if you divided by 0, like, you know, in, I don't know, the 70s or something, your computer just crashed. Thankfully, computers are smarter than this now, right? Because it's impossible to divide by 0, really. It's even more impossible to divide 0 by 0. Thankfully, MATLAB knows to be like, that's not a number, you know, and that's what it does basically, is it has the special number representation called nan. All right, so anyway, the main point of all that is to just say the weird thing that you have to get used to about matrices is, you know, if you have 2 rows by 5 columns, there have to be 10 things in the matrix, right? You can't have just 9 things in a matrix that's a 2 by 5, right? Okay. That's not always a big issue, but it's something worth thinking about. Like, so in other words, here's another good example of why that's important. So let's say, and I'll introduce a new little piece of syntax to you at the same time. So let's say A is going to be the numbers 2, 4, and 6 in a row, okay? And I want to see what A is. It tells me it's 2, 4, 6 in a little matrix like this. And if I ask what the size of A is, it's 1 by 3, meaning it has 1 row with 3 columns, okay? So there's a lot to unpack there. And again, don't worry about memorizing all this now. A, it's going into the podcast. B, I'm not really formally teaching it. I'm just trying to get you guys familiar with the flavor of MATLAB. But one thing you'll notice here is that what I did, if I wanted to define A as a matrix, and not as a matrix that's returned as the result of a function, but if I want to literally type in the values of the matrix, I put it in little, I hope you can see, they're square brackets, right? Or what Americans would just call brackets. So not parentheses. So it's the same notation that you would use in Python for a list, not a tuple, right? So again, in MATLAB, there's no distinction between what you would call lists or tuples in Python. Anybody remember the key difference between lists and tuples in Python? All right, so tuples can't be changed once they're created, right? In MATLAB, no rules like that. MATLAB's just crazy that way. So you can change anything you create in MATLAB. So maybe that's one easy way to remember it, is when you are making a matrix, you use square brackets always. Now when you're accessing the values in a matrix, as I did up here, you use round brackets or parentheses, right? So there's some differences in usage. I will tell you right now, I'm sure you guys will forget this thing. You'll be using the wrong types of brackets all the time. That's okay. You'll get used to it. This is part of the, it's like a rite of passage of becoming a programmer, is like forgetting your semicolons all the time, mixing up your parentheses and your brackets. It just happens when you switch programming languages. But it's really good to sort of train your mental flexibility to get used to doing it, a couple different ways with slightly different notations. Okay, so anyway, so I put the numbers 2, 4, 6 in a row in brackets. And if I really wanted to, this is really how you usually do it in Python, I think, is you put commas between them. But Matlab doesn't really care if you put a comma or not. As long as they're spaced out, it knows that that's a row of numbers. So we've set A to be equal to 2, 4, 6. And we've looked at the size of A, and it's a 1 by 3 matrix, right? Meaning it has 1 row and 3 columns. Okay, so the question is, what if I want to add a value to A, but I don't want to, so if I want to add a value to the end of it, I could do something like this, A 1, 4. Now what this means is the value in row 1, column 4 of A equals 8. That, what it knows, MATLAB figures out when you say that what you really want to do, it's like, well, there's not a column 4 already, but you're trying to put an 8 in column 4 of row 1, so I'll just I'll expand A to be a new matrix with 4 columns and put 8 in that 4th column, right? So that works. What if I try to skip a column? So if I try to skip right ahead to column 6 and put a 12 in there, what do you think happens now? Well, it could be anything. But the answer is, it's okay with that, but it automatically fills in a 0 for any information you didn't specify. So if you imply that you want to expand the matrix, but don't put a value in for something that, so in other words, you can't have a column 6 without a column 5, right? And you said what you want to put in row 1, column 6 is 12, but you didn't say anything about what you would put in column 5. So, so it just puts in a 0. Okay, everybody kind of with me so far? Everybody kind of cool with this? One thing I should have mentioned already. Has anybody caught on to one fundamental difference between how MATLAB and Python refer to items in a list or a matrix? I guarantee this is going to screw you over time and time again until you beat it into your head. So if I want to refer to the first item in A, what number did I use to refer to the first item in A? Do you guys catch that? So if I want to see A in row 1, column 1, right, that's the first thing in A. In Python, what would I call it? What number is the first item in a Python list? 0. Very good, everybody remembers. All right, yeah, that's going to screw you over many times until you get it into your head. So some programming languages, like C and Python, use the number 0 to refer to the first thing in a list or a matrix or whatever. MATLAB uses 1. Okay, that's because mathematicians usually use 1. If you've ever done any linear algebra and you see a matrix, they refer to the indices or the rows and columns of the matrix as starting at row 1. MATLAB is ultimately a mathematical tool for mathematicians originally. So it uses that notation. This is going to blow your mind over and over until you get used to it. And if I try to say, what is item 0, it will give me an error, right? If I try to see what's in row 0 or column 0. Now the only case where this gets a bit funky, the only place where 0 comes into play is, like I said, even if you want to represent nothing, meaning not the number 0, but like an empty matrix, you can actually make something like that. So if I wanted to make a variable called C, that's a totally empty, it's like an empty box with nothing in it. You can do that by just putting some brackets with nothing in them, and C is an empty matrix. I know you would say, why would you ever do this? But it's very useful sometimes. What do you think the size of C is? Anybody got a guess? Okay, you might guess 0 or 0 by 0. It's 0 by 0. Sometimes, though, it comes up as 1 by 0. Like I think, let me see if we make C equal to 5, and then we say, so size of C is 1 by 1, and if we say C So if we want to get rid of an item, whoops, it's not going to let me do that. Now we can have an empty matrix that's 1 by 0. So there's some weird things about, so really 1 by 0 or 0 by 0 is both an empty matrix. All right, so there's a bunch of weird things that you can do with MATLAB. It takes a long time to get all the little syntactic tricks down. Again, don't worry about the details. This may sort of be messing with your mind. You don't have to memorize all this stuff. The thing to keep in mind is, again, you're playing around with matrices. You can sort of insert and take out values from the matrix, but there's sort of some fundamental properties of matrices you can't change. So I'm really showing you more than you need to know here at the moment, but this stuff may be useful when you get into handling like bigger pieces of data. When we start out really programming though with you guys, we're going to be doing things more the way we did it in Python, and then like gradually folding in the way to do things in a more matrixy way. Okay, so I'll show you just a couple more quick things, just to prove to you that again matrices have to be like the right shape. So if I want to make a 2, 4, 6 in the top row, and then 1, 3, 5 in the bottom row, that's something I can do. What you notice is, again, this is another weird piece of syntax you just have to learn. If I put a semicolon in here, that means I'm starting a new row, right? And what you get is a row that's 2, 4, 6, and then a new row that's 1, 3, 5, and the size of A is a 2 by 3 matrix. Okay, very good, right? If I try to specify that A is 2, 4, 6 on the top row and just 1, 3 on the bottom row, I get an error. Doesn't matter, don't worry about this error message. What that really means is you can't do that because you didn't put enough items on the top row. So again, I could put a 0 in or something like that, but I have to put something in. Something has to be in each position in the matrix, okay? And if you try to do something funky to resize the matrix, like if I want to say, no, I really want to get rid of that 0, so I want the value in row 2, column 3 to be empty, it doesn't like that either, okay? It doesn't like you trying to set an individual element of the matrix to be empty. But you could do, don't worry about this right now, I could set all of the second row to be empty, and that's totally cool because it maintains a rectangular shape for the matrix, right? So basically the idea here is all matrices are, they may be lines, which are one-dimensional matrices, right? They may be squares, which are 2D matrices. They may be cubes of numbers, but you can't have any like missing chunks, right? It has to be a complete square or complete cube or whatever. Okay. I know this is maybe not making a ton of sense. I'm not sure, but again, the point to keep in mind is that everything is represented as a matrix. Now, this has some weird implications, okay? So for example, let's say, forget about A being numbers, right? So let's say this is a string, right? So this is a string. One common command, the equivalent of print in Python, is called disp in Matlab. So if I just want to display A, it prints out this is a string. Again, in Matlab, you can also just put the name of the thing in, but it will also put A equals to tell you that what it's doing is revealing the value of a variable. Disp is literally just saying print that to the screen and do nothing else. But what is this string? This is a string, really. Well, one thing that you can do with A is you can do some funky things like you can treat it just like a matrix. So let's do it this way. So let's say A equals, this is a string, this is another. Let's see if that works. Okay, I need to count some characters. I think I need a space here. Okay, so what is this really? Well, A is still a string of sorts, right? But what did I do here? I actually put two strings, what we would think of as two strings in Python, on top of each other. In other words, what A really is, it's displaying it a bit differently, but what A really is a matrix of letters, okay? So that means it didn't like this is a string on top of this is another, because those are not the same lengths, right? But if I put like, or if, just to make it a little clearer, this is another exclamation point. That works because this is a proper matrix. It's a 2 by, well, if we want to see what the size of A is, it's a 2 by 16 matrix, meaning it's 2 characters tall, 16 characters wide, and you can stack up strings like that. Which means also, if you're really curious as to what the, let's say, the second row, third character is, should be an I, you can do things like second row, third character of A, it's the letter I. If you wanted to see what the fourth character is of the second row, it's S, right? So even though strings look like text, they're actually really just, you can think of them as matrices. They're just like a bunch of numbers in a row, arranged in, a long string this way, or a 2x5 matrix, or whatever. You could have 3-dimensional strings, you could have 5-dimensional strings, whatever. Even, like, strings are really no different than numbers, except that they print differently, okay? And they're treated as, there's no other word than matrices. They're treated as matrices just like numbers are. Does that I know this is sort of weird to think about. This is the weirdness of MATLAB. Does that kind of make sense to everybody-ish? We're going to get into more of this later. The main point I want to just drive home is that everything's a matrix, okay? Anybody got questions about that? Or like, this is the kind of thing where it's great to play around. You can play around in the MATLAB command window all day, and I have. That was most of my grad school. Like just sort of figuring out sort of the weird tricks of syntax, of like the various characters that you can use to do little tricks in MATLAB. But this, I just want to give you a quick intro into how this stuff works. Okay, so I realize I did not do one thing here, which I should have done. So we're going to take, maybe we'll take a quick break because I'm sure you guys are like zoning out a bit. And when we resume, I was going to show you just like a quick Psychopi demo to show some of the stuff that you can do in Psychopi. And then maybe we'll spend the rest of the time on your project. So people good for a break now? Yeah. All right. So break time. All right. So while we were on the break, what I did is I forgot to copy a file over from my personal user account to the account I use to present lectures and such. But I just wanted to show you guys a brief example of something I cooked up while I was playing. This was just me playing around with PsychToolbox a few months ago. So I'll maybe show you some more real-life experiments later. But this is to just give you an idea of something that like I could do in MATLAB that would not be super easy to do in Python. So the file is called, you see I copied it into the folder that's in my Documents MATLAB folder. It's called PTB Frame Rate Demo, which is just PTB as my abbreviation for PsychToolbox. And so if I just type edit that in the MATLAB command window, you see it pops up the editor window. Again, you'll see some very nice things about the editor window. It'll look a bit different in the current version, but it'll still be basically like this. Some nice things are like up here it tells me warnings found. This is that whole online code editing thing that's amazing. It tells me things like, oh, I might not be using that function that I wrote, which is true actually because I commented out that function in the code. And similarly, it tells me that this function is not used in the code. So there's some really nice things. Those are the only errors in my code right now. So congratulations to me. And those are not actually critical errors. They're just warnings saying that I have a function that I never use. So there's some really nice stuff. Again, you'll get used to this later, but if you look at the code in MATLAB, like you won't really know what a bunch of this means. But one thing you might notice is that it has very nice highlighting. It's got green for the comments. You'll notice the comment character is different. It's the % sign instead of the hash or the octothorpe character. You see it represents a lot of important keywords like function and if in blue. That tells you those are kind of special words. We'll talk about the syntax of all these later. You'll see some very familiar things like while. Function is the version in MATLAB of what we call def in Python. So you'll see some kind of familiar language features. But this probably still looks, you see that there's else if, which is just like what in Python. If you've got an if and an else, MATLAB calls it else if. What does Python call it? I think it's elif. Is that what you said? Yeah. So that's another one that's just going to mess you up constantly until you remember. It's just a choice that they made, right? Like Python makes it a bit shorter by saying elif. MATLAB spells out else if, right? So it's just something to keep in mind. But anyway, so this is a piece of code I wrote. So here's a little code I wrote. You might want to sing it up or not. Okay, we can just continue that. Let's see if this works with the projector. Hopefully it will. And I'm not sure how much this will work actually with the podcasting software. We might break it, but let's see. Oh, maybe not. That would be awesome if we don't. PsychToolbox works on a very low level in the operating system, so there's a pretty good chance this won't show up on the podcast, but we'll find out. Okay, so that's just a standard thing I put up on my tasks, because a lot of the time you might want to care what your screen refresh rate is. In this case, that 60 hertz is fine. All right, so here's an example. Oh, it looks a bit funky, actually. This should actually, hang on a minute. One of the warnings I got was that I needed to change my screen resolution, but let's just tell it to set the screen resolution to what the actual resolution is. Okay. You'll notice it starts up much faster the second time you run it. Okay, so here's one example. Now, you might ask yourself why I did this. It sort of looks like the Hypnotoad from Futurama right now. This was just something I was wondering about as a psychophysics experiment that I've never actually looked into yet. Do you guys notice any difference between those two circles? Those look at all different to you? Does anybody detect a difference? Everyone looks confused, so I guess that means no. All right, so now let me change something in the code to a different demo. This is when you become, full-blown nerds and learn how to program anything you want. You can do things like this. Like every time you start wondering about something, you can just code up something and test it yourself. So all I did is change the function I'm calling to present the stimuli here. But I preserved most of the same settings. Do you notice a difference here between these two rotating lines? Yeah, okay, so does everybody see that? Again, it's probably not too visible on the projector, but they probably both look a little bit blurry from motion blur, but does the right one seem jerkier to everybody? Okay, so that's one weird thing I noticed. I don't do this all the time, but I was playing an iPad game, and it had a stimulus. It had like a thing on it that sort of was a changing color. And what I noticed was, well, I don't know. So let's go back to the color version of the demo. This is actually an interesting psychology question that I don't know the answer to, or a vision question. So in both of those demos, the difference between the left and the right stimulus is that the left one is changing at 60 frames a second, and the right one is only changing at 15 frames a second. But what's weird is you can see the difference in the rotating lines, and you can't really see the difference in the changing colors, right? Does everybody kind of agree with that? So that's kind of weird, right, that your eyes have a different resolution for changing color like this. Now, part of it is a little bit of a cheat, because part of it is just that part of that motion blur is in the display. So really I need to try this with a non-LCD display, because LCDs show a lot more motion blur of moving objects than if you're using the same pixels and changing their color. But the other thing I noticed about this, which is a bit weird, so what is your sensation that you experience with this? Do you feel like the color change is equally gradual all the time, or do you feel like it rests on certain colors longer than others? Do most people kind of feel like it rests on some colors and then kind of quickly transitions to others? So that's another weird effect. I really want to look into whether this is, I have a theory about why this is. But just to prove to you, I have a third demo. Oh, sorry, the right one was going at 20 frames a second, not 15, but same basic idea. All right, so this is one more demo. Again, this is just what I do on my Saturday afternoons when I'm bored, when I'm not marking your papers. No, I'm just kidding. I did this far before there were any problem sets to mark. I did this last summer. So this is proof that I think this is both of these going at, this is both of these going at 20 frames a second. So this is showing on the left a color wheel with the line representing where on the color wheel the right circle is. But what's weird is the line kind of looks jerky while the color appears to be changing smoothly, right? And you can see, the line's position represents the exact color that's on the right at any given time. So you can see that the line is sweeping smoothly through this color wheel. But yet, there is this sort of weird sensation that the colors are kind of pausing and then quickly zipping to the next color. Do people kind of feel that? That's kind of a neat. I've never, I mean, I haven't, this may not be a very interesting psychological effect, and it may be well established, and I just haven't read the literature. But I have some ideas about why this is. I mean, the colors you'll probably feel like it's pausing on. Like, it also corresponds, I think. Does it also look like this color wheel is kind of in wedges of color? Do people, or does it feel smooth and continuous to everybody? So to me, at least, what it looks like to me is like there's a big wedge of blue and kind of a quick gradient, and then a big wedge of cyan. You know what I mean? It kind of looks like this is a wedge of green, this is a wedge of yellow, this is kind of a big wedge of red, but there's a little bit of orange at the edges. You know what I mean? But this is actually, so the point of this color wheel is, this is a perfectly gradual transition of the red, green, blue values. Like it's, the numbers that represent these red, green, and blue colors, just like in Python, are just changing the exact same amount as you go around the circle. But at least to me, it feels like there's a bigger difference between like here and here on the circle than like here and here. Does that feel the same way to people? So my theory, at least, if you care about this, is that I think the colors that seem to be not changing are blue, like there's like a blue patch, a red patch, a yellow patch, a kind of greenish patch, a cyan patch, and a magenta patch. And those are the six primary, well, the six primary colors that are represented by the red, green, and blue. So it's either an artifact of the monitor or it's an artifact of your eyes, and I'm not sure which it is. But remember, you have, because both this LCD projector has red, green, and blue pixels, and then red plus green makes magenta, blue plus green makes cyan, and green plus red makes yellow. And that's the same as in your visual system, right? You have red, green, and blue cones, and then they combine to make those other colors. So I'm not really sure whether it's your visual system or the RGB tricking us, but that's my feeling, that like it seems to pause on like magenta, red, yellow, green, cyan, blue in those 6 places. Anyway, this is not useful at all unless you really wanted to get into the psychophysics of color vision, which would require much better equipment. But this is the kind of thing that I could just quickly mock up. Now, it took about 300 lines of MATLAB code, which might sound like a lot, but about 100 of those were like just sort of standard starting up PsychToolbox code that I just copy and paste between experiments. And then it was like, so this is the function that writes the rotating lines. So that's like 30 lines of code. Same thing for the one that writes the changing colors. That's like 30 lines of code or so. And it's a little bit longer for the one that like shows the changing circle and the sweeping line, but it's still not that long. But anyway, the cool thing about this is I had to use a bunch of MATLAB's like sort of built-in number manipulation functions and like functions for dealing with colors as numbers and so forth. But it's actually pretty easy to do if you kind of know a lot about MATLAB to whip this up in an hour or so of kind of playing around with MATLAB. So it'll be a while before you guys are at kind of that level of just tinkering around. But that's the kind of thing that like you could do that in Psychopi too, but it would involve importing a lot of modules that are basically designed to emulate what MATLAB does. So it's sort of more direct to do it in MATLAB. All right, so anyway, any questions about the MATLAB stuff? Everybody good? All right, so we'll end the podcast for today. We'll probably do, so next week we'll probably do all supervised playing around with your projects, because I suspect we won't have MATLAB yet next week. But we've got about 20 minutes or so to do more supervised talking about your projects, so we'll do that now.